I'd like everybody to do something for me. Look down at your shoes. And if you can, take one off. I'll do it too. Common ground. Let's go. So, maybe you chose your shoe because it was cheap. Maybe because it's fashionable. Maybe it's comfortable. Doesn't really matter, right? It's just a shoe. But what if I told you that your shoe may have traveled over 100,000 kilometers before it even reached you? Your shoe may have traveled more of the world than you have. But this isn't actually a story about shoes. This is a story about everything we buy, everything we consume, and everything we throw away. It's a story about the relationship between production and place. And it asks one fundamental question. What would it look like to redesign that relationship? So I'm going to take you on an indicative journey that your lucky shoe might have made before it reached you. We start in Texas, where crude oil is extracted to make synthetic materials. Rubber, which is usually what your sole is made from, that is extracted in Malaysia or maybe Thailand from rubber trees. The leather, that comes from cattle in either Argentina or Brazil. And it's tanned in Bangladesh or in India. Synthetic materials like polyester is spun in China, and those tiny little eyelets, those are pressed in Taiwan. If you have laces in your shoes, the cotton may have been grown and picked in Egypt and then processed in a dozen other places around the world. All of these materials converge in one factory where they're actually put together by hand. Then they're boxed and they're shipped in shipping containers all over the world to distribution centres. And then, once you've used your shoes, once they're either worn out or you've grown out of them or they go out of fashion, well, they may travel again, ending up in landfill. Maybe somewhere like this, maybe in Ghana. But this isn't just shoes. This is for most of the products in our life. Our phones, our jeans, maybe even your morning coffee. We have built a system where materials travel thousands of kilometers far more easily than ideas used to. We optimized for cost in isolation, but in doing so, we have increased global inequality, waste, and carbon emissions. The footwear industry alone annually contributes 700 million tonnes of CO2 to the atmosphere. That is actually more than commercial international air travel. And we made ourselves fragile. Everybody probably remembers the pandemic, when global supply chains froze and we realized just how dependent we'd become. For decades, cities have been operating on a simple model, the PITO model: product in, trash out. We import finished goods, we consume them, and then we export the waste. Production happens elsewhere, extraction happens elsewhere, and pollution, well, that goes elsewhere. In this linear extractive model, process and place becomes disconnected from what sustains it. Waste materials, they leave our sight, but they never leave the planet. There is another possibility. The answer is not to go backwards. This is not about rejecting modern processes. This is about using technology differently. Today, we have digital fabrication, we have distributed manufacturing, open source design, renewable and regenerative materials. We have urban data systems and local energy generation. What if we used these tools to rebalance globalization? Imagine this. The design for a customizable shoe is shared globally as open source data, but it is manufactured locally, perhaps somewhere like a mid-scale factory in Linz, using resources from the own region's waste stream. It is repaired in your neighbourhood. The materials are recycled locally at the end of life. Fewer container ships, more local capability, waste becomes material. This is a shift from PITO to DIDO, data in, data out. Design travels globally as data, knowledge circulates, and innovation is shared. But production, that happens locally. Intelligence is global, but the material metabolism is local. That is one way to redesign the relationship between production and place. But this is not about one product. This is about redesigning the full stack of the city. From materials and fabrication, to skills and education, to projects for local needs, communities and placemaking, local systems, bioregions, data and governance. In extractive systems, we try and fix one layer at a time, a project, a policy, a product. But real change happens when the layers align and we address the whole system. A city partners with a neighbourhood fab lab or makerspace. It maps its waste streams and its material flows. It supports mid-scale local production. It invests in repair networks and shared workshops. It connects local innovators with global knowledge. This is the approach that Fab City takes. Fab City is a foundation that brings together a global network of over 50 cities, including Linz. They are working together to look at one simple provocation. By 2054, can cities produce most of what they consume? Not by recreating old factories and industrial models, but by building circular, place-based systems in a distributed fashion. Designing global and making local. And each place in this network interprets the model of the full stack differently, based on the culture, the governance, and the bioregion. But they share knowledge. When one city prototypes a design, the files are shared instantly. Data in, data out. And each location becomes both a learner and a teacher. And this transformation does not start in policy documents. It starts in practice. For example, in Bali, Indonesia, communities facing energy instability are working with local fabrication labs to prototype hydrogen capture systems. They learn about electrolysis, amperage, digital fabrication, not because it's part of a syllabus, but because their livelihoods depend on it. In Hamburg, in Germany, designers and engineers are designing mid-scale urban manufacturing facilities using open source design and tools. They learn not in classrooms, but about material availability, energy use, and production systems by really building an urban manufacturing system in their city. Across the world and across this network, repair cafes are popping up to expand and extend the life of products. Urban farms are shortening supply chains. Citizens are learning by solving real problems. This is not education in theory. This is education embedded in place. In places like the Grand Garage here in Linz, that is creating a common ground, a common learning space. And when capability grows locally, resilience grows locally. So, imagine cities in 2054, that they produce everything or most of what they consume. Knowledge travels at the speed of light, carbon travels less, energy is generated locally, materials circulate locally, food systems are shorter, production is visible again. The quality of products improves through customization. Cities remain globally connected, but materially grounded. That is redesigning the relationship between product and place. So, I want you to return to the shoe. Hold it in your mind's eye and think, what if it were actually created within 50 kilometers of where you stand? If you knew where the materials came from, if you could repair it, if at end of life it became a city resource. This transformation does not begin with national policy. It begins with small actions that we can all take. You can support a local repair cafe. You could visit a local Fab Lab. You could explore material availability in your neighbourhood. You can choose your products wisely. You can support a local repair workshop. You can visit a makerspace. You can choose your products wisely. Ask where they came from. Share your knowledge openly and participate in your city's material future. Because redesigning the relationship between production and place is not just a technical shift, it's cultural. Let ideas move at the speed of light and materials move at the speed of ecosystems. The future is not something that we wait for. We build it together. One open design, one circular material flow, one neighbourhood workshop at a time. And it begins exactly where you are standing